One of the biggest advantages that an AC supply has over a DC supply is the ease with which the value of alternating voltage can be raised or lowered with great efficiency by the use of transformers. It can also easily be converted into DC by the use of diode rectifiers. Transformers and diode rectifiers are often used together in transformer rectifier units. In this lesson, we will look at the operation of both transformers and diodes. We know from previous lessons that when a current passes through a conductor, a magnetic field is produced, and that the strength of the magnetic field can be enhanced by wrapping the wire in a coil and giving it a soft iron core. We also know that when a conductor is moved through a magnetic field, cutting the lines of flux, an electromotive force is induced in the conductor. It is these principles that are used in transformers. A simple transformer consists of two electrically separate coils of wire wound around two opposite sides of a laminated soft iron core. The coils are known as the primary and the secondary windings. The primary winding is connected to an AC supply, and the output is taken from the secondary winding. The alternating voltage and current in the primary winding creates an alternating flux, which flows through the core and cuts through the coils of the secondary winding. This induces an EMF in the secondary winding, which is available as the output AC voltage. If a load is placed across the terminals of the secondary winding, then an alternating current will flow in the circuit. In electrical diagrams, a transformer is usually indicated by the symbol shown here. The transformation ratio of a transformer is the ratio of the number of turns or coils of wire on the secondary winding, N2, to the number of turns of wire on the primary winding, N1. The transformation ratio is also the ratio of the output voltage to the input voltage. A coil with 100 turns of wire on the secondary winding and 400 on the primary will have a transformation ratio of 100 divided by 400, or 0.25. We can now use this ratio to calculate the output voltage of the transformer. If, in this example, the input AC voltage was 115 volts, the output voltage would be 115 multiplied by 0.25, or approximately 29 volts AC. A transformer with a transformation ratio greater than 1 is known as a step-up transformer, whilst a transformer with a ratio less than 1 is known as a step-down transformer. Transformers are almost 100% efficient in their transfer of power from the primary to the secondary windings. So for all practical purposes, we can say that the power that goes into a transformer equals the power that comes out of it. From this, we can say that the product of the voltage and the current in the primary winding will be equal to the product of the voltage and current in the secondary winding. It is important that the input supply to the primary coil of a transformer is of the correct frequency. Transformers are inductive devices, and if the input frequency is low, it is possible that the transformer will overheat due to excessive current flow. The output of a three-phase AC generator can be transformed by using either three single-phase transformers or a three-phase transformer, which consists of a laminated core with three limbs on which are wound the three sets of primary and secondary windings. An autotransformer uses a single winding on a laminated core with a pick-off at a predetermined point along the coil. As you can see, part of the coil carries both the primary and secondary current because it is common to both windings. Autotransformers are less expensive than two-coil transformers because they use less materials. However, one of the major advantages of two-coil transformers is that the primary and secondary circuits are electrically isolated from each other, and this is not so in autotransformers, so their use is limited to situations where this is not important. Where AC is required for the operation of instruments on the aircraft, autotransformers can be used to either step down or step up the source supply to the required voltage. The supply usually required for instruments is 26 volts AC. A rectifier is a device which will convert alternating current into direct current. The most common rectifier in use in aircraft systems is the solid-state diode rectifier. The electrical symbol for a diode rectifier is shown here. The diode is a semiconductor device, and its operation is fully explained in the lesson on semiconductors. It has a very low resistance to current flow in the direction of the arrowhead, and a very high resistance in the other. If a diode rectifier is placed in an AC circuit, it will allow current to flow through the load in one direction only. This is termed half-wave rectification. Current will flow through the load in one half cycle, but in the other half cycle, when the polarity of the voltage is reversed, the flow of current will be blocked. This method of rectification will therefore produce pulses of DC in the secondary circuit, with gaps between the pulses. To produce DC without gaps in the pulses, a full-wave bridge rectifier, as seen on the screen, can be used. The bridge has a diode rectifier on each leg. The AC supply is connected across the bridge at points A and B, and the output is taken from points C and D. In one half of the cycle of the AC input, point A will be positive and point B negative, so current will flow through the bridge and the load in the direction shown. In the next half cycle, the polarity will be reversed, making point A negative and B positive. However, because of the arrangement of the diodes, the current flows through the load in the same direction as before. The output of a bridge rectifier consists of pulses or ripples of DC. These usually need to be smoothed electronically before being used. A much smoother supply, without large peaks and troughs, can be produced from a three-phase supply by using a three-phase bridge rectifier. A three-phase rectifier superimposes the full-wave rectified output from all three phases on top of each other. Thus it produces a much smoother output than a single-phase rectifier. The output of a three-phase rectifier can therefore be considered to be of a steady DC voltage. There is another type of diode rectifier you may come across, known as the Zener diode rectifier. The symbol for a Zener diode is shown here. This type of diode, again, allows unrestricted current flow in one direction, but if the polarity of the voltage is reversed, it will block current flow, until at a predetermined voltage drop across the diode, it will allow reverse current to flow without restriction. Zener diodes are often used in voltage regulator circuits. Transformer rectifier units, or TRUs, convert AC at one voltage to DC at another voltage, in order to supply the DC needs of an aircraft with an AC distribution system. The TRU combines the transformer and rectifier in one unit. The input supply is usually 115/200 volts, 400 Hz, three-phase AC, and the output 28 volts DC. The TRU current output can normally be monitored by the pilot, either on a gauge or an electronic screen. Some aircraft types, which have a frequency-wild AC distribution system, use transformer rectifier units to feed static inverters to supply the aircraft's normal constant frequency requirements. This is done by using the TRU to change the frequency-wild AC into DC, and then using the DC to power the inverter, which will produce a constant frequency AC output. That is the end of the lesson. Here are the main points that you need to take from it. Transformers are used to raise or lower the voltage in an AC electrical system. An autotransformer has only one coil. Autotransformers with an output voltage of 26 volts are often used to power instruments. In a step-up transformer, the output voltage is greater than the input, but in a step-down transformer, it is lower. The power in the primary winding of a transformer is equal to the power in the secondary winding. The input supply to the primary coil of a transformer must be of the correct frequency. If the input frequency is low, it is possible that the transformer will overheat due to excessive current flow. A diode rectifier has a very high resistance to current flow in one direction and a very low resistance in the other. A bridge rectifier produces an output of full-wave rectified DC. A three-phase bridge rectifier produces a steady DC output voltage. A Zener diode acts in the same manner as a normal diode until a predetermined reverse voltage is reached, at which point it allows unrestricted current flow in the reverse direction. Transformer rectifier units, or TRUs, convert AC at one voltage to DC at another voltage, in order to supply the DC needs of an aircraft with an AC distribution system.